Hello, this is the 8th lesson of Unit 3, which is our polynomial unit. In this lesson, we're going to look at the relationship between dividing polynomials and the remainder and factor theorem. So long division, it's just like when you were taught to divide, let's say like 18 into, let's say 389. You would take 18 and look at the 38 first, figure out how many times it would go in there. Go about twice, that's 36. Then you change the sign, draw the line and add them, get 29. Now it'll go in there about once. And you get 18, change the sign, draw the line, and you get 11 left over, and so you can write that as a fraction, 21 and 11/18. I hope you remember doing that at some point previously in your schooling. If not, then you can kind of get used to it. You can even go online and practice some of those dividing and using the remainder as a fraction. So now we look at polynomials. You can only do this if you have a 1 as the coefficient on this binomial. So it has to be a linear binomial. And you would look at this and say x will go into 2x cubed, 2x squared. 2x squared times x is 2x cubed. 2x squared times negative 3 is negative 6x squared. Just multiply it. And now I suggest that you change the sign to each of these on the inside and add. That's exactly what you're doing when you're subtracting, is you're changing the sign and adding, because 4 minus a negative 6 would be 10. So 10x squared. This should always wipe out that front one, or else you've made a mistake. Drop down your 0x. Now the whole reason we had to have a 0x there was we needed a placeholder. You have to go down in standard form, 3, 2, 1, and then this is your x to the 0th. That's why you have to have the x the first as a placeholder. Now x, we go to the next one. X will go into 10x squared, 10x times. 10x times x is 10x squared. 10x times negative 3 is negative 30x. Draw the line, change their signs, and add. Those two will wipe out. We get 30x, drop down the 5. X will go into 30x, 30 times. X times 30 is 30x. Negative 3 times 30 is negative 90. Draw the line, change the signs, and add. And that would be 95. You'd write that as a fraction here, plus 95 over x minus 3. Okay? So that's how you do it. Here, they're saying this polynomial that you just divided by x minus 3 equals 2x squared plus 10x plus 30, just bring down your answer, 95 over x minus 3. When you perform long division of polynomials, why must the degree of the remainder be less than the degree of the divisor? So why couldn't this be an x minus 95? The reason is because x could go into x. When it becomes a degree less than the divisor, then it shows you that your divisor can't go into it any further. It'd be like a number bigger than 18 on this original problem. You know, 18 could go in there again. If you have an x in here, then you know it can go in again. Here it could go into that x. Okay, is the set of polynomials closed under division? Well, no, because you can even look at this answer. That's a rational function. It's not a polynomial. You can't have x on the bottom in a polynomial. So no, it's not closed because your answer isn't always a polynomial. Remember, if they're closed, then the answer has to be that number group. Okay, now we look at the remainder theorem. And what this says is that remainder is actually the answer if you were to plug that number in. So, for example, right back here where we took x minus 3 into this, if we set x minus 3 to 0, we would get x equals 3. If you plug 3 into this, replacing the x, so you went 2, 3 to the third, plus 4, 3 squared, plus 5, 3 to the third is 27, times 2 is 54, plus 3 squared is 9, times 4 is 36. 36 and 54 is 90. Now if we add 5, that makes 95. That is our remainder. And that's what the remainder theorem says, is that when you divide x minus a, the remainder is the same thing as if you took this a value and you plugged it into the polynomial. Okay, now there's also synthetic division that you can do in order to find this answer. Synthetic division is a little bit quicker than the long division. Here's how it works. You would take x minus 3, and you would say x minus 3 equals 0. Find your x value. X equals 3. Now take that 3, put it right here, and take your coefficient to your first term, coefficient to your second term. We go 3, 2, 1. We don't have a 1, so we have to, an x the first, so we have to put a 0 as a placeholder. And then this would be your x to the 0th, because that's your constant. So you only put your coefficients, drop down the first one. So we have 2. Now 2 times 3 is 6. Add 4 and 6 is 10. 3 times 10 is 30. Add 0 and 30 is 30. 3 times 30 is 90. 5 plus 90 is 95. So that last digit in synthetic division is your remainder. So, on the reflection, if a polynomial px is divided by x minus a, then px divided by x minus a, we're just showing a proof here, just like you have in geometry. So let's just kind of step through this. We're saying this is equal to this, and we're trying to get rid of the bottom of the fraction, so we multiply each side by x minus a, so it'll cancel it out here. This ends up needing to multiply by that, but when it multiplies by this one, it would cancel that one. You're distributing it to each one. So they show the first one being distributed, but on the second one, you would end up with x minus a times r over x minus a. So do you see how those two will cancel? And you just end up with r. Now, because we are substituting a in for x, because we're seeing that x minus a is the value that we want to substitute in, we can substitute a for x. We're going to substitute it in. This ends up being 0. A minus a would be 0 times qa equals the remainder. 0 times anything is 0. So we have just proven that p of a will equal your remainder. It always does. Whatever your remainder is, that's what it was when you plugged it in. So let's practice on one. These are pretty fun. We want to do x plus 5, so if we set that to 0, x plus 5 equals 0, That means x equals -5. Just subtract 5 to each side. So we have -5. Now let's check our coefficients. That was to the x cubed, x squared, x, and x to the 0. So we don't need any placeholders. We drop the first one down. We have 3. 3 times -5 is -15. Remember, we're adding. So -15 and +14 is -1. -5 times -1 is +5. We add 5 and a -1 would be 4. -5 times 4 is -20. We add those together, we get 0. So we have no remainder. Our answer is actually 0 when we plug -5 into this polynomial. Over here, filling in the blanks, they're stepping you into this. They say if x plus 5 equals x minus a -5, they show it a little bit different than I did up here. What's your a value? So your a value would be -5. Write the value of a in the upper left-hand corner, and then they step you through how to do it. Write the quotient, the answer here. We would go down a degree because we're dividing it by x, so it would go down, x goes into x cubed, x squared times, so it's 3x squared minus x, 1x, plus 4. Okay? What is the remainder in this example, and how do you know? Well, we know that the remainder is 0 because in synthetic division, that's what we end up for, is the remainder. We could also check to see that it's 0 by plugging in 0 into the polynomial. You need to write these. I'm not writing them, but you need to. Can you use synthetic division to divide 3x cubed plus 14x squared minus x plus 20 by x squared plus 5? I told you that it needs to be a linear binomial. That is a quadratic binomial. So the answer is no. In order to use synthetic division, we have to have an x, just a linear, so that we can solve that. Okay, now we have to understand the factor theorem. And basically what the factor theorem is that if the x minus 5 up here, or x plus 5 I should say, if it is a factor, then your remainder will be 0. So in other words, this times this, we could FOIL that and we would get this, because x plus 5 is a factor where it had a 0 remainder. That's all that the factor theorem is saying, is that when your remainder is 0, then that you get the number from is a factor. Okay, so now what we want to do is complete the proof of the factor theorem. And again, these are from geometry. Hopefully you got pretty good at proofs in there. So we're trying to say that the remainder, well, we know that it is the answer to P of A. And we know from our last proof that we had that the dividend equaled the divisor times the quotient, the x minus a, plus the remainder, which can be substituted as P of A. Now realize P of A is 0 for the factor, so it's just 0 there. So what we say is that x minus q, or minus a, times qx, right there, is equal to P of x. Now x minus a is a factor of px. So you can see right there it's a factor. It's being multiplied by whatever that is. Assume that x minus a is a factor of px. then x minus a times qx. We can substitute a in for the x, again, just like we did before, because we're putting a in the formula, we substitute the x, so a minus a times q of a. A minus a is 0 times q of a. Doesn't matter what q of a is, the 0 wiped it out, so it's 0. Okay? So now let's look at the factor theorem. Show that x minus 4 is a factor of x cubed plus 2x squared minus 21x minus 12. Okay? Then write px as the product of x minus 4 and another factor. So the first thing is set x minus 4 to 0. We would find that x equals 4. Now check that we don't need a space holder. We have x cubed, x squared, x, and x to the 0th. That's the first. Okay, we're in good shape. Drop the 1 down. 1 times 4 is 4. Add these two. 6. 4 times 6 is 24. 3. 4 times 3 is 12. 12 and negative 12 is 0. Now we go down in a degree, so we know that that is x squared plus 6x plus 3. Up here, the synthetic substitution shows that p of 4 equals 0. In other words, if we plug the 4 into that polynomial, it would equal 0. Now we can say that x minus 4, what we divided in, is one factor. Multiplying it by x squared plus 6x plus 3 would result in the original polynomial. We'll be doing some of that in class. Show how to check the factorization you wrote as in the last step. You multiply, so you'll take these two and you'll FOIL or box it right here. Please do that. Do not leave these blank. I need you to do that. So FOIL or box it. I check to see how well you did on that. This practice we'll do in class tomorrow. Thank you very much.